Okay, I guess I'm online now. Good evening and a very warm welcome to all of you to joining us at this Reading Climate Festival event of Reading. I'm Michaela Häglin. I'm Associate Professor at the Meteorology Department and the chair of this online event. Tonight's discussion topic is Not All Doom and Gloom, the good news from the cutting edge of climate science. Well, looking at news items over the past couple of years around the world, wildfires in southern Europe, extreme flooding in Germany and China, extreme temperatures at the west coast of Canada, all likely harbingers of climate change, could make the most ardent optimist feel desperate. Indeed, it is doom and gloom if we do not change the course we are currently on. That is why the message to the world for COP26 is that we need to act now. That is also why it is all the more important to direct our attention to climate solutions and actions that have the potential to change the course we are on. And in order to discuss current science knowledge and local climate actions, I'm very pleased to introduce three of my colleagues tonight, Professors Richard Allen, Nicolas Belloin, and Tim Dixon. Richard and Nicolas both work in the Department of Meteorology and on the physical understanding of climate change. And they were both lead authors in the most recent Intergovernmental Panel on Climate Change IPCC report. The IPCC is the United Nations body for assessing the science related to climate change. Tim works in the School of Construction Management and Engineering. He has a strong focus on sustainability, leads the Reading 2050 research at the university, and he is also co-chair of Reading Climate Change Partnership. We invite the audience to ask questions throughout the session using the Q&A tab on the right of your screens. And I will go through as many questions as we have time for after the presentations are over. There is an option to post a question anonymously if you wish and you feel more comfortable about it. Before we begin, I would like to make you also aware that this event is being recorded, including the Q&A. So there will be a chance to watch it back later. I hope you will enjoy this evening's event, and Richard, over to you.
Okay, well, thank you very much, Michaela, and thanks for attending the talk today. So I'm Richard Allen, University of Reading at the Meteorology Department. So if you pop onto the next slide, me and Nicola have been working very hard over the last 3.5 years, along with hundreds of other scientists on this Intergovernmental Panel on Climate Change report. So we are dealing with the underlying physical science basis for climate change. And what this involved is it's getting hundreds of authors together assessing thousands of scientific peer-reviewed publications and making an assessment of what is the state of the art knowledge of climate science at present. And this involved a number of peer, reviews by many reviewers, and involved lots of different scientists from around the world. But also what was crucial about this IPCC report is the fact that it goes for approval to basically 195 governments delegates have to approve line by line the summary for policymakers, which I was involved in August. And so that gives this report an extra clout because it means that the governments have already bought into this process. They've already approved the key findings from it. So it gives a really great importance for this report in terms of supporting the COP26, which is being held in Glasgow soon, where the policy action will be discussed and agreed. So next slide, please. So we already know that Earth's climate has always changed. We've seen the lava in La Palma at present, pretty frightening scenes, but we know geologically that the continents drift over many millions of years, and we know the world was a very different place on these vast timescales. We also know that if you went back 20,000 years, we're in the middle of the last glaciation. Ice sheets were moving across northern Britain, North America, northern in Siberia, and it was a very different climate. And we know this. We understand why, that the Earth's orbit around the sun it changes periodically and predictably, and we know how this initiates these huge changes from glacial cycles to the current interglacial period that we're in now. So we know that Earth's climate has always changed, but all the evidence now points to the fact that humans are the cause for the current change. Things are changing far too quickly to be explained by natural causes. They cannot be explained by anything other than the human activities, primarily emitting carbon dioxide through burning of fossil fuels. So the recent climate change, which is outlined in the IPCC report, it's widespread, it's rapid, and it's unprecedented in thousands of years. These human activities, we know, are already, as we've seen on the news and Michaela mentioned, already intensifying extreme climatic events, including heat waves, heavy rainfall and associated flooding, and making some droughts more severe, and it will continue to do so in the future if the planet continues to warm. And what's known from this report is that with every bit of warming that the planet undergoes, the magnitude of warming and the severity of climate extremes will increase. This is a known, it's based on some basic physics, it's based on more complicated assessment of all the lines of evidence. And what's also known from this report is the fact that limiting warming to what's considered safe levels, so below 2 degrees C above pre-industrial times, or if we can, below 1.5 degrees C above pre-industrial times, it requires immediate, rapid and large-scale reduction in greenhouse gas emissions. This is absolutely clear. This is what the science says. Next slide, please. This is one snippet from the report, delving more deeply into the report. It shows what the carbon fluxes are, the carbon dioxide fluxes, and it's measured in billions of tons of carbon. What you can see is the blue arrows show natural fluxes and the brown arrows show the unnatural fluxes. That's us, human activities. Now, what you can see is that compared to the natural fluxes, the human activities are creating quite small changes. There's massive natural fluxes year on year. But the fact of the matter is, these fluxes of carbon dioxide out of the land and into the atmosphere, out of the ocean and into the atmosphere and back in again, they're balanced on a year by year scale. So what comes out goes back in. So when the plants grow in the northern hemisphere land, they take carbon in and then they decay later on in the year, and that carbon goes back into the atmosphere. Now what we're doing is tipping the carbon cycle out of balance. So we're emitting nearly 10 gigatons of carbon per year into the atmosphere through burning of fossil fuels, also cement making, and also an extra 1.6 gigatons of carbon, billion tons of carbon per year through land use changes. Now, if all that carbon dioxide stayed in the atmosphere, we'd have even higher levels than we've got at the moment. We've got 415 parts per million, which are well outside of anything that we've seen even in the last 2 million years. Luckily for us, some of that carbon is being uptaken into the land, so plants are growing more rapidly, the land is taking up carbon, but also the ocean is taking up some of that carbon. And what's being left behind, this 5 gigatons of carbon, is what's causing year on year the levels of carbon dioxide to grow in the atmosphere by around 2 to 3 parts per million per year, more carbon dioxide in the atmosphere. And that is what is driving climate change primarily. So next slide, please. So this warming is driven by carbon dioxide because that's altering the energy budget of the atmosphere. So it's impeding the flow, the cooling of energy out to space through infrared radiation. It means there's more energy arriving than leaving. That's causing the planet to warm until it gets back to an equilibrium. And we know this based on multiple lines of evidence, based on some basic physics and complex physics. We base it on observations of the past, observations of the present, and crucially, we code up all the physics that is well understood into complex computer simulations that split the planet into a complex grid and mesh of simulates weather systems, weather patterns. It simulates the whole atmosphere and deep into the ocean and the land surface as well. And what this graph here shows is that we can use these simulations as a laboratory. we can run these simulations with what's happened in terms of the carbon dioxide emissions and other greenhouse gases, and we can run it just with the natural factors, so changes in the sun making it more or less bright that we've observed, and volcanic eruptions that go off sporadically. The last massive one that affected the climate strongly was the Pinatubo eruption in the Philippines in 1991. Now, when we do this, we can show that basically all of the warming that we've observed over the last 5 decades or so is caused by human activities. It's driven by primarily carbon dioxide, but also other greenhouse gases like methane, nitrous oxide, and this is driving warming of the climate. This warming is amplified by vicious cycles or feedback loops. So, for example, when the planet warms, ice melts, and this reflective surface diminishes, it means more sunlight's absorbed. That can amplify the warming. Similarly, there's more water vapor, moisture in a warmer atmosphere. That similarly is a stronger greenhouse effect, and that amplifies the warming. So warming is amplified by these feedback loops. Now, pollution from other particles, like aerosol particle pollution, has actually caused an extra reflection of sunlight, and that's offset a little bit of the warming, quite a bit of the warming, so it's not warmed up quite as much as it would have been without it. But of course, we don't want this pollution because it's bad for our health as well. So the bottom line is natural factors cannot explain warming based on all the lines of evidence. It's all down to human activities, primarily CO2. So next slide, please. So putting in the context of the longer time scale, we can see that over the last 2,000 years, climate, if anything, was cooling slightly. This relates perhaps to the orbital cycles that we know about, cooling the climate very slowly over thousands of years. But this rapid warming over the last 100 years of getting on for about 1 degree C is massive compared to what we've seen in the past. Warming is what the IPCC report shows. The warming is faster since 1970 than any other 50-year period in at least the last 2,000 years. And the warmth of the last decade that we've experienced is probably comparable to the last interglacial period, 125,000 years. So going back, most of the time was in glacial periods. Going back 125,000 years ago, we were back in another interglacial or mild period. We think it's kind of similar to that period now, but going back to that period, based on the evidence, it's thought that sea level was actually 5 to 10 meters higher. Now, that was a sustained warming, not just a decade, so it takes a long time for sea levels to rise to that extent, and I'll mention that in the next slide. Next slide, please. And we can run these simulations that I mentioned before out into the future under various scenarios. So we can give them low emission scenarios, high emission scenarios, middle range scenarios. And the top left plot just shows the range of temperatures we can expect globally. So if we have a high emission scenario, we can expect maybe up to 5 degrees C of warming by the end of the century. Now, this is colossal, because if we went back 20,000 years ago into the depths of the last glacial maximum, the planet was about 5 degrees C colder. So you can see that a 5 degrees C warmer world is basically a completely different world. And to make matters worse, it's absolutely unprecedented in millions and millions of years. So it's a completely serious thing to contemplate. However, if we go on the low emission scenario, we can keep the level of warming to 1.5 degrees C above pre-industrial. So that's a good news that what we do can affect how much warming we can expect. But we can only reach these, limit this warming to these values if there are deep reductions in CO2 and other greenhouse gas emissions occurring in the coming decades and sustained for many decades. What the bottom left plot shows is that under the low emissions scenarios, we retain our Arctic ice, whereas under all the mid and high emission scenarios, we can say goodbye practically to Arctic ice at this time of year in September because it's too warm to sustain that ice. We can also see that sea levels rise in this bottom right plot to between ½ a metre out to the end of the century in the low emission scenarios, out to about 1 metre in the high emission scenarios. And what the IPCC report has also looked at is that we can't discount some unlikely events of these big dynamical slippages in ice in Antarctica that could make sea level rise maybe even by up to 2 metres by the end of the century. If you click next to get the animation on this slide, please. And what you can also see is if we go out to 2300, so in a couple of 300 years time, obviously we're not going to be around then, but humans hopefully will be, sea levels will rise by between maybe up to 3 metres even under the low emission scenario, and maybe as high as 7 metres or even higher under the high emission scenario. This just shows that sea level rise is a long-term problem. It takes hundreds and hundreds of years for the deep oceans to heat and expand, and it takes hundreds and hundreds of years for giant ice sheets to over Greenland and Antarctica to come to its new equilibrium and add more water to the oceans. And over these long time periods, it's irreversible that we will definitely get sea level rise, but these are over very long time periods. But still, it paints a pretty bleak picture. Next slide, please. So what are finally, and just also to say that the water cycle is the way we'll really experience some of our extremes. We'll see more intense rainfall and associated flooding. When droughts occur, it'll be hotter, it'll be drier, more intense droughts are likely. Wet events will be wetter, dry events will be more severe, and there'll be increased variability from day to day, but also from year to year. That's some of the evidence coming out of this IPCC report. So next slide, please. And just to finally say that what we do know as well, in terms of the good news, is that we can do something about it. We know that for each 1,000 billion tonnes of CO2 that's emitted, the planet will warm by about 0.5 degrees C. So if you click down once again, you can see that under the low emission scenario, if we emit a maximum of 3,000 gigatons of carbon, we can limit the warming to 1.5 degrees C. Whereas if we go above this limit, we'll go above this, what's considered a safe level. And so what this means is we know what the course of action is. We know that we've got to rapidly, substantially reduce CO2. We've got to do this across all sectors, everywhere, and in a sustainable way, in partnership across different systems, locally up to government scale, and it's got to be collaborative. So we know what the solution is. So now that's the good news, that we know what to do. The doom and gloom, of course, is that if we don't do anything, as Michaela said at the beginning, there's a pretty dire picture for our future planet. I'll pass on now to Nicholas, who will mention a few more snippets from the IPCC report that offer glimmers of good news as well.
Thank you very much, Richard. And we'll go to the next slides, please. So Richard already gave a few pieces of good news, but there are more indications that the physical understanding that we have of how the Earth works gives us a chance to limit global warming and climate change. And there are positive aspects in the report, but one needs to look hard. And they tend to be a bit technical, so I'm going to spend a bit of time to explain them. So the first positive news is on committed warming. So you may have heard that there is warming in the pipeline, is that even if we stop emitting CO2 emissions overnight, then the Earth will keep on warming, because the ocean is storing heat and will keep on warming and heating for many thousands of years. And that is true, but when you look at climate model simulations, there's another picture emerging. So the figure on the left shows the change in temperature after we stop CO2 emissions abruptly. And year 0 is when the emissions stop, and you see that the simulation go into the future 100 years after emissions stops. And you see the gray lines are the results of different models, and you see that they paint slightly different pictures. But on average, that's the black line, you see that the temperature doesn't change that much. Once we stop emitting CO2, then there's no more warming. So that's surprising, because we expect CO2 to continue to warm, we expect the ocean to continue to warm for many, many thousands of years. But what happens is that when we stop emitting CO2 in the atmosphere, the land, the vegetation, the soil, and the ocean will continue to take some of that CO2 out of the atmosphere, and the CO2 concentration will start decreasing. And that will start reversing the warming. And so there is a compensation between the warming of the oceans that continues and the decreasing concentrations of CO2 in the atmosphere. So nature will help us there when we stop emitting CO2. Next slide, please. The second bit of good news is on the pathways to 1.5 degree warming. So first, it is worth reminding why it is good to avoid warming too much. A figure on the left shows maps of temperature change. Red is warmer. Precipitation change in the middle column. Green is wetter and brown is drier. And then soil moisture change, again, moisture in green, drier in brown. And you have 1.5 degrees at the bottom, 2 degrees in the middle, and 4 degrees in the top row. And you see that the more we warm the planet on average, the stronger the impacts are locally, and especially in the change in precipitation and soil moisture that we rely on for our livelihoods. So clearly, we don't want to go towards very high warming levels. On the right is a little time series that shows the years where different warming levels, 0.5 degrees, 1, 1.5, 2, 3, and 4, indicated by the colors going from white to red, when those warming levels will be crossed. We have already crossed 0.5 degree warming. We have already crossed 1 degree warming. Now the question is when 1.5 degree warming will be crossed. And you see here, this is where we have the choice. We could follow a trajectory that's the one at the top, which is labeled scientifically SSP 5.8.5, which is a very high emissions trajectory, relying on fossil fuels. And you see that we would be at 1.5 degree by the end of this decade, and we would be at 4 degrees by the end of the century. Or we could follow the trajectory at the bottom, which brings us to 1.5 degrees around mid-2030s. And then we will go not much over that, 1.6 degrees maybe. And then we go back down less than 1.5 degrees by the end of the century. So the top trajectory, the very warm one, is very unlikely at the moment. We're already cleaner than what that trajectory implies. But the problem is that the bottom trajectory is also very unlikely at the moment. We don't decrease CO2 emission enough to follow that one. So the next slide, please. Third positive news is on climate feedbacks. So climate feedbacks are when natural processes respond to climate change and may either dampen the initial change or enhance the climate change. So here it's worth looking into what's called carbon budgets in some details. So since the year 1850, we as a species have emitted over 2,000 billion tons of carbon dioxide into the atmosphere. And at the moment, per year, we emit about 40 billion tons of CO2 per year. So to have 2 out of 3 chances to stay under 1.5 degree of global warming, we have a budget of 400 extra billion tons of CO2 that we could emit. That's our budget. And you see, that's essentially 10 years worth of emission. But the fear is that maybe we're not completely in control of that budget, and some natural processes responding to climate change actually emit CO2 and steal some of our budget. So those processes could be thawing of permafrost in the tundra, and release of ocean cloud rates on the ocean floor. Wildfires, these have been in the news a lot lately, which of course emit CO2. But the good news is that the estimates of all that is that they may only take 26 billion tons of carbon dioxide out of our budget. It's very uncertain. It could be much more than that. And also, those feedbacks become much stronger at high warming. So that's another reason why we want to limit global warming to low values. Next slide, please. So that's the last piece of good news that can be taken from the report, and something that Richard mentioned, and some positive news on methane. So here the story is that we now understand fairly well what drove past climate changes. So if the little bar on the left, the little histogram shows observed warming, so about 1.5 degree, 1.1 degrees, sorry, for the past decade. And that warming has been driven mostly by carbon dioxide, but also methane. And you can see in blue, there are some changes that actually cool the climate, mostly due to particles of pollution. But we work hard to improve air quality because bad air quality shortens the lives of millions of people. But that means that we are getting rid of a cooling influence of the climate, and we will get warming from that. So the good news is that we can counteract that warming by reducing the emissions of methane. And that would have a win-win. We limit warming, but we also improve air quality further because methane itself is an air quality pollutant. But you can see that carbon dioxide is still the main driver, and if we want to stabilize climate in the long term, we need sustained reduction in carbon dioxide. So that was me with some good news maybe buried in the report. And now I'm giving the floor to Tim, who is going to talk about what can be done locally to respond to climate change.
Okay, thank you very much indeed, Nicolas. And a really big thank you to Richard and Nicolas for setting out the evidence so clearly. If I could have the first slide, it might take a little while just catching up. So I think the kind of key message that I wanted to get across, building on the scientific expertise that we've just heard about, is it's not too late, but we don't want to run it too close, because action needs to be taken now to deal with these really big impacts that we're having in terms of climate change. So what I wanted to do in the few minutes that I've got before we hand it over for questions and answers is really to look at some of the sort of more recent history, if you like, and context to the way that we've approached climate change within local authorities, but also how we as individuals can really make a difference in our everyday lives, and looking in particular at some of the work that I've been involved in locally with the Reading Climate Change Partnership. So could I have the next slide, please? I think, you know, we've all seen the iconic Ed Hawkins climate strikes, which has even reached the catwalks of the world, and that message, that clear message, has really made a powerful impact, I think, in the imagery and the concise way in which that kind of portrays climate change. It's really impactful, and it's made a big difference. And I think the other background and context to this is that climate activism, you know, we think about the work of Extinction Rebellion, but also the Green New Deal movement, that has really played an important role in changing the mindset of politicians and making sure that we do now focus on the immediacy of the climate change peril that we face. You know, we saw the standoff between Greta Thunberg and Donald Trump at the World Economic Forum in 2020. It didn't turn out very well for the guy on the right. I wouldn't say the battle has been won. In terms of the debate, there's still a huge amount of work to be done. Could I have the next slide, please? And so when we look back actually to the 2018 report, which was published a couple of years ago, that was really important in kind of creating the momentum for local authorities globally and in the UK itself to declare climate emergency declarations, spurred on by the activism of the groups that we've just talked about. And I think that was a really important moment. You know, we can talk about a turning point for climate change. That was certainly a turning point. We hopefully haven't quite yet reached a tipping point, which is when we can't reverse these things, but we're certainly getting much closer to that moment. And we all know that the evidence now is speaking not only from the past, but the present, to making sure that we do something about it now and not wait. And that's been strengthened, of course, by the UN report about the way in which international and national carbon emission strategies have really failed to address the importance of climate change. Can I have the next slide, please? So that piece of recent history kind of led to a big movement across the globe in terms of declaring these climate emergencies, and Bristol was actually one of the first cities in the UK to declare an emergency in 2018, but other cities such as Manchester and Bristol followed. And actually it's interesting to note that more than 300 local authorities in the UK in March this year had some form of climate declaration in place. So this is really important for us in making sure that we tackle the problem. Can I have the next slide, please? And I thought it was useful to compare the way in which the local authorities across what we might term broadly Berkshire or the Thames Valley region have approached this issue. So we can see that pretty much all of them have some kind of climate emergency declaration in place. There's a bit of shifting and shaping around the targets, whether those targets are net zero, where offsetting probably isn't quite as important as it might be in a carbon neutral world. But what we're trying to do in achieving a net zero end result is to reduce emissions through mitigation to balance out production and consumption elements within that equation, but also to make sure that any offshore offsetting that we do happens locally, so it has a real impact locally. And you can see that the target dates also vary. There's some really challenging targets here set by West Berkshire, Reading and Wokingham for 2030. But when we look at the pattern of emissions over those 6 unitary authorities, we can see that there's a gentle decline over time. The statistics show that Reading's emissions as a borough fell by nearly 50% from 2005 to 2019, but a lot of that was created by the fact that low carbon energy was going back into the grid. So again, that's not a reason for us being work to do. And one of the interesting things to note is that just recently, the Local Economic Partnership, which stretches across the Thames Valley, commissioned a piece of work from Bioregional, which is looking at how these different unitary authorities can work together with the LEP to partner business and to kind of fill in the gaps that there still are around the different strategies in those local authorities. Can I have the next slide, please? I thought it was also useful to highlight the fact that we've done things differently, haven't we? You know, as individuals and as communities and in the cities that we live, the COVID crisis actually, ironically, fast forwarded a lot of the things that we were doing anyway, and it gave us some big wins in terms of, at the time at least, reducing emissions. But we've bounced back from that now, and we're continuing to create emissions. But I don't think the lessons that we learned from COVID have disappeared. You know, it engendered a much more climate positive behaviour in the way that a lot of people approach their lives. Cycling lanes were introduced in cities, and we saw air quality improve, at least temporarily, in many parts of the world. And of course, pedestrianisation as well, even some redesign of city economies, like we see in Amsterdam, for example, the circular economy operating there, and lessons from Paris, thinking about the 15-minute city, Mayor Hidalgo convinced that that's going to make a big difference in Paris, and we're seeing initiatives like that in the UK as well. Can I have the next slide, please? But it's still a very fragmented picture, isn't it, at national level in the UK, but also regionally and locally. There's lots of different stakeholders involved in this whole net zero and climate change agenda, and I've just listed some of them for you there. But you know, perhaps the main three key stakeholders that we see operating in Reading, at least, are we as individuals, but the local authority itself, and businesses. But there are other stakeholders as well that have a real important role to play in tackling climate change. Can I have the next slide, please? Local authorities have got a really tough time, really, you know, in terms of the COVID impact, the way it's impacted on all of their services, but they're doing their very best to help drive this impetus towards tackling climate change. We've seen lots of initiatives from councils improving the energy and carbon efficiency of their estates, trying to generate and promote green electricity on the grid, the movement towards low carbon electric vehicles, promoting walking and cycling, and lots of other initiatives, you know, tree planting, improved waste management and so on. So there's lots of things that local authorities are trying to do. Can I have the next slide, please? And there's lots of things that we can do as individuals. This is actually taken from the Reading Climate Change Partnership website, where you can sign up to take a pledge to do these activities. And actually the university has signed up as an organisation to take the pledge and to do lots of activities which reduce waste and improve energy efficiency and so on. But we as individuals in our everyday lives can use less heat in the house. We can only use appliances when we need them. We can take a shower instead of a bath. There's lots of things we can do. We can have meat-free days. We can recycle more. We can buy less stuff. We can even write to our local MP about climate change, and we can plant trees. All of these things are valid things to do that do, in aggregation, make a difference. Could I have the next slide, please? And we've seen lots of activities locally, things like the Reading Hydro Scheme, which is a really fantastic community project, the Reading Community Energy Project, which our very own Dan Fernbank has been involved in. And then a bit further west, the West Berkshire Climate Finance Bond, which has promoted through crowdfunding the opportunity for investors to buy into renewable projects so that they then get a payback. So it's like a green investment bond. Lots of really good examples emerging locally and regionally. Can I have the next slide, please? And so here in Reading, we formed the Reading Climate Change Partnership back in 2009. And that brings together a board of now 15 people. We're all voluntary, but we all come from different walks of life across Reading. The income that we have to operate is actually, ironically, from the solar feed-in tariff. So there's a kind of virtuous circle there. And we're hosted by Reading Borough Council, but we also link a lot with the different elements of other visions and strategies in Reading, including the Reading 2050 vision, but also including the economic recovery strategy, which has a strong focus on green growth and climate change, and now the new Reading Business Improvement District, which has a green focus. I was at an event earlier on, and there's lots of exciting initiatives working through from that. Can I have the next slide, please? And so we also have a network which supports us and is a very active part of what we do. This is called the Reading Climate Action Network. So that brings together communities and organisations from across Reading to be able to tackle climate change. Can I have the next slide, please? And so our target audience is really everybody who lives and works and studies in Reading, and the university is a very important player in that and has its own net zero carbon strategy as well. Can I have the next slide, please? And so we're focusing on different elements. We have theme leads stretching across transport and energy, but we're particularly focusing on decarbonising transport, looking at retrofitting housing at scale, generating new renewable energy, as we saw earlier, a strong focus on resources, consumption and waste, but also really important nature-based solutions. We can't just rely on natural systems, as David Attenborough has said recently, but we will do everything in our power to make sure that nature can help us and promote good quality life and end results in tackling carbon emissions. Can I have the next slide, please? And so you can find out more by logging on to that website. Tracy Rawling Church, my co-chair, she's done some fantastic work this week in putting all these different activities together with her comms team. So a big thank you to her, and it's great that we can be part of that programme. Can I have the next slide, please? So this is my final slide, really. It's just putting things a little bit in perspective to re-emphasise the point that we mustn't be complacent. There was an interesting piece of research that appeared in the media which suggested that the word cake was 10 times more popular in terms of its mention on British TV than the term climate change. So I guess lots of people must be watching the Great British Bake Off or something. Maybe we need to refocus our vision there. And it's interesting as well when you look at this slide, you know, that climate action and climate crisis are not as common in terminology as climate change. I said earlier, it's about thinking what we can do as individuals, and that comes back really to thinking about education, how we can be advocates for making a big difference locally and regionally, but recognizing that we do need to take action sometimes, and it's about leadership, isn't it? This is the crux of the matter now in the run-up to COP. What the eyes of the world are on Glasgow, and the UK government will need to really focus on providing leadership. So thank you.
Thank you very much to all our speakers for 3 fantastic and very insightful presentations. Thank you very much. If I take away a message from what we just heard, is that the IPCC has indeed issued a very stark warning that climate change is upon our doorstep, and that if we do not take immediate action, the consequence of climate change will just grow. And what we also saw is that the future is really in our hands. So with our personal and societal choices and strong immediate actions at the local to the global level, we still have a good chance to avert the worst. And we also saw from Tim that there is already a lot of action going on at the local level in our council, and that is really good news to me. I will now move on to the Q&A session and pick up some questions in the remaining time. Let's see what we have here. There's a question from Paul, who asks, what key messages should we should we be telling our students studying GCSE and A-level geography? And this is not a question that I would ask all of the three speakers to kind of maybe mention what they would think, what the key messages could be to our students.
I guess you can hear me. Well, the key messages really, I think, would relate to the syllabus that students learn, and they learn about past climate change, they learn about glacial cycles, they learn about current change. So I think making it clear that the scientific understanding of climate change is there, and that the current changes are caused by human activities. So that's the key message to link, that we know that the climate is warming because of human beings and their activities. And then to make the case that what we can expect if the planet warms further in terms of impact relevant changes. So these will be increases in intense rainfall and associated flooding, when drought events occur, how much more severe they can be, and when hot events occur, how much more severe they can be. And the two kind of key messages, I think, would be that you have to avoid these getting any worse. You've got to mitigate, which is to rapidly reduce CO2 and other greenhouse gases down to net zero, so we're emitting out the same as what's being drawn back in to the Earth system. But as well as mitigating, we need to adapt. We're inevitably going to have to adapt. We're going to have to adapt to these more severe extreme weather events through, as we've seen in Germany, better preparedness, better warning systems, that kind of thing. And in terms of sea level rise, for example, in terms of building infrastructure that's able to cope with what is expected to happen. So I think the three things, the key messages would be: human activities are causing climate to change. Without mitigation, these extreme events will become worse, and some aspects of the climate system are inevitable, and these will need to be adapted to by society. And GCSE and A-level geographers will be well placed to deal with many aspects of these, as well as science students. Anyone else?
Yeah, Nicola, please go ahead.
Yes, just to emphasize the importance of the need to decrease CO2 emissions, but I think it's also fair not to burden them with that responsibility. It is often heard that it will be up to the young generations to essentially remove the CO2 from the atmosphere somehow with some technologies that don't quite yet work, and to pay for that role themselves. I think it is necessary to emphasize that all generations now are part of this work to decrease emissions rapidly to avoid dangerous levels of global warming.
Michaela, would you like me to just respond to that as well in terms of?
If you have, I have another question for you. But
okay.
Maybe first another one to Richard, because it's more on the physical climate side, and that one that also I am interested in the answer to. What one piece of evidence would you use to convince climate change skeptics?
Yeah. That's a very good question, and it kind of depends on what their level of skepticism is. Do they accept that CO2 is a greenhouse gas, that it's capable of warming, or are they skeptical of, is the planet warming? So, I mean, there's three key observations that I think are kind of useful. One is looking at the ice cores, which are like a million-year time machine. The deeper down you go into Antarctica, the further back you go, and you can actually show that levels of CO2 bobbled about in the last million years between 180 and 280 parts per million. And so current levels are so far outside of that, 415 parts per million, you know, it's blindingly obvious that something pretty different is going on. You can also use evidence from the fact that this CO2 has its own special, this fossil CO2 that we're burning has its own special signature, because it's very low in the radioactive form, carbon-14, which is naturally produced in the atmosphere. The fossil form in coal and oil, it's all the radioactive decay away. So essentially we can show that we've diluted the atmosphere with this fossil carbon. It's us, we've caused the CO2 to be there. There's also satellite data that you can show that shows the imprint of CO2 in very specific particular bands of the electromagnetic spectrum. It shows definitively that these CO2 increases over the last few decades, based on satellite data, have reduced the amount of cooling that the planet can achieve. And obviously, if the planet can cool less, it's going to heat up until it warms up such that it balances the absorbed sunlight again. So that's another key piece of evidence. And the other key piece of evidence, I think, would be the temperature record. You know, just looking at the last 100 years in the context of the last 2,000 years of reconstructed temperatures, it shows what a huge and rapid and widespread change this is. So those are kind of the areas that I'd deal with if talking to a climate skeptic.
Thank you. Thank you very much, Richard, for this answer. Maybe I would also add that maybe you should go and talk to converted climate skeptics, like the people living in Alberta in Canada, who kind of experienced the big wildfires in the nearby state, and that from being climate skeptics, they are now really talking about climate change really happening. Okay, a question to Tim though. Why are West Berkshire emissions the highest of our local authorities? Is it area and or rural environment that we are living in?
I think that's a good question. I think the environment does impact the way that we emit, you know, in terms of buildings, transport and other activities. Certainly in West Berkshire, because of its size and its rural location, then transport is going to be a big issue. So that's probably really why the emissions there are higher. And that would be in terms of per capita as well. You know, if you do the statistics globally, you often find this difference between per capita emissions in a city, because you've got lots of people living fairly dense together, and then the per capita emissions in the countryside, which, because people are spread and have to travel more, commuting and so on, that would probably be the reason why we're seeing that difference in pattern. So I think that's probably the answer to that particular question.
Okay, thank you, Tim. Maybe another one for Richard or Nicola. 1.5 or 2 degrees temperature increase does not sound much of a change to some. How can we convince people it really is?
Yeah, that's quite a common question, a good question. So I would refer back to that. We know that the 20,000 years ago, the last glacial maximum, when ice sheets were across northern Britain, when sea level was 120 meters lower than it is now, the planet was around 5 degrees C colder than it is now. So it kind of puts into context what how big a 2 degrees C rise in temperature is. If we were going down, reducing by 5 degrees C, and we were living in essentially quite a different planet almost. So it's a huge effect. And the fact as well that we know that if we sustain even 2 degrees C of warming over many hundreds of years, we have a sea level rise of maybe 4 meters, maybe 5 meters. So that kind of underscores how what a huge warming it would be. Nicola, do you have any addition?
Yeah, perhaps remind people that we are at 1 degree now, and we are already experiencing very strong extremes, and the summer has been especially full of such examples in Germany, in Canada, in Russia, the climate science is now advanced enough to tell us that those events, like the floods in Germany, for example, are due to human climate change, and that's something that's already evidence that we're struggling with, and it's only 1.1 degree, right? So yes, every fraction of a degree matters, because the impacts are essentially proportional to the warming that we experience.
Okay, thank you both for these answers. Maybe possibly another one for Tim, especially because I do not quite know what the Scope 3 emissions are. The Reading net zero target for 2030 excludes Scope 3 emissions. Does this make sense? Is it enough?
I think that's a good question. I mean, if we're thinking about an organisation or a business, in general terms, Scope 1 emissions would be to do with direct emissions, i.e. using fuel. If we're talking about Scope 2, it's to do with electricity purchased, and then Scope 3 emissions would be to do with all the other things in the supply chain, which might be more difficult to influence. So I think in setting Scope 1 and 2, that's a reasonable start in terms of achieving net zero, but that's not to say that we're not encouraging other organisations across the Reading area to extend their targets to include Scope 3, because in a way it's easier for an organisation to do that than it is for a large borough. But of course, the university, in setting its individual net zero target to 2030, is also taking into account Scope 3 emissions. So I think we'll see a refocusing on this element as we move through the piece, but we are engaging with business also to encourage companies. You know, we've got some really big multinationals like Huawei and Microsoft. That's great, but there are lots of SMEs and smaller companies that could all play their role in helping us achieve the target of net zero and climate resilience by 2030. So I hope that helps answer the question.
All right, thank you, Tim. Maybe one last question before we have to stop, but one that is possibly very, very relevant, and I'm not sure who of you wants to answer that one. Do you think more developed countries have a duty to support less developed countries in reducing their impact on climate change? And if so, how? Tim, can you?
Yeah. I mean, I think it's good that we've seen the United States promising much more in terms of funding for tackling climate change to the developing world. But, you know, it's very unfair, isn't it, when we think that individual footprints in developed nations are a lot higher than they are in the underdeveloped nations. And so getting that balance is really crucial. China's obviously playing a major role in at least setting a target of peak emissions by 2030 and promising not to build any more coal-fired stations abroad, but that's not a particularly challenging target, you could argue, in one respect. The other thing is that, you know, on the downside, we only have 11 countries across the world that have embedded net zero targets within their legislation. So the UK is one of those, but China and the USA haven't done that, although obviously since Greta Thunberg and Donald Trump had the standoff, America has now come back into the Paris Accord with Joe Biden signing up to that. So it's a bit of a mixed picture internationally at the moment. I don't know whether Richard or Nicholas wanted to add to that.
Yeah, I think we should stop, because we are already at 7 o'clock, and I'm afraid that that's all the time we have for this evening. We hope you found the event enjoyable and informative. And as mentioned already, the session has been recorded, so you can rewatch using the same link you used this evening to join in. If you'd like to know more about climate science at the University of Reading and what we are doing about climate change and what you can do, visit our Planet Partners Hub at reading.ac.uk/planet. You may also be interested to know that the university has also launched a free online course with the Walker Institute called Planet Partners Tackling the Climate Crisis Together. This course is designed to provide participants with the confidence to talk about the impact of climate change and feel empowered to act. While it is aimed at 16 to 18-year-olds, it can also be taken by anyone from around the world who wants to learn more about the impact of climate change. And to access the course this course, visit futurelearn.com. But we will put the links for you into the chat box as well. So again, thank you again for attending tonight. And again, thanks a lot to our speakers for their fantastic presentations and the interesting discussions. And we hope to see you at another university event very soon again. Good night, everybody.